Good day, I am David Sinangote. This is my laboratory exercise number 2, and the title for this activity is Kinetics and Chemical Equilibrium. So the objectives for this activity is that at the end of this exercise, you are expected to make a record observations, measurement, and approximations, interpret and evaluate experimental observations and data. General direction: study the two experimental setups. Answer what is asked appropriately. Number 1. Identical pieces of brass were placed in two different boiling liquids for 12 hours. The graphs show how the mass of each piece of brass changed. Graph A shows brass in boiling acid solution, and Graph B shows the brass in boiling basic solution. Question A. Give one similarity in the change in mass of the brass in both liquids. So the similarity in the change in mass of the brass in both liquids is that they are able to change in mass in the given time. Question B. Describe two ways in which the loss of mass shown in graph A is different from that shown in graph B. So in graph A, it shows a continuous slope up until 12 hours. On the other hand, graph B has a change in slope when reaching 9 hours until the 12th hour. Second is that, as you can see in graph A, it shows a slower rate rather than graph B since it has a steeper slope. Question C. List 3 different safety precautions that are needed in doing this investigation. You need to wear gloves, wear a goggle, and a lab coat. Number 2. The rate of reaction between hydrochloric acid and aqueous sodium thiosulfate was investigated. When these chemicals react, they form a precipitate which makes the solution go cloudy. The formation of this precipitate can be used to show how fast the reaction continues. 5 tests were done using the tools shown below. Test 1. Using a graduated cylinder, 60 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask. The conical flask was placed in a printed sheet of paper. 10 cubic centimeter of the hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. Test 2. Using a graduated cylinder of 50 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask, followed by 10 cubic centimeter of distilled water. The conical flask was placed on the printed sheet. 10 cubic centimeter of hydrochloric acid was added to the sodium in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. Test 3. Test 2 was replicated using 45 cubic centimeter of aqueous sodium thiosulfate and 25 cubic centimeter of distilled water. Test 4. Test 2 was replicated using 35 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. Test 5. Test 2 was replicated using 10 cubic centimeter of aqueous sodium thiosulfate and 20 cubic centimeter of distilled water. These are the total time for the printed words to disappear. Letter B question is plot the results on the grid and draw a smooth line graph. This is my solution for the graph, and it totaled 125 seconds for printed words to disappear. So question C, from your graph, infer the time for the printed words to disappear if test 2 was repeated with 15 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. So I got 125 seconds for printed words to disappear from the 15 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. Letter D. In which test was the rate of reaction greatest? So test 1 has the greatest rate of reaction because as we increase the volume of aqueous sodium thiosulfate, the time for the printed words to disappear decreases. Therefore, the greater the volume of aqueous sodium thiosulfate, the faster reaction it creates.